3.5 CMOS steady-state electrical behavior. This section discusses the steady-state behavior of CMOS circuits. That is, the circuit's behavior when inputs and outputs are not changing. The next section discusses dynamic behavior, including speed and power dissipation. 3.5.1 Logic levels and noise margins. The CMOS inverter's behavior only at two discrete input voltages. Other input voltages may yield different output voltages. The complete input-output transfer characteristic can be described by a graph such as Figure 3-25. In this graph, the input voltage is varied from 0 to 5 volts. As shown on the x-axis, the y-axis plots the output voltage. If we believed the curve in Figure 3-25, we could define a CMOS low input level as any voltage under 2.4 volts. And a high input level as anything over 2.6 V. Only when the input is between 2.4 and 2.6 volts does the inverter produce a non-logic output voltage under this definition. Unfortunately, the typical transfer characteristic shown in Figure 3-25 is just that, typical, but not guaranteed. It varies greatly under different conditions of power supply voltage, temperature, and output loading. The transfer characteristic may even vary depending on when the device was fabricated. For example, after months of trying to figure out why gates made on some days were good and on other days were bad, one manufacturer discovered that the bad gates were victims of airborne contamination by a particularly noxious perfume worn by one of its production line workers. Sound engineering practice dictates that we use more conservative specifications for low and high. The conservative specs for a typical CMOS logic family, HC series, are depicted in Figure 3-26. These parameters are specified by CMOS device manufacturers in data sheets like Table 3-3, and are defined as follows. VOH-min the minimum output voltage in the high state. VIH-min the minimum input voltage guaranteed to be recognized as a high. VIL-max the maximum input voltage guaranteed to be recognized as a low. VOL-max the maximum output voltage in the low state. The input voltages are determined mainly by switching thresholds of the two transistors, while the output voltages are determined mainly by the on resistance of the transistors. All of the parameters in Figure 3-26 are guaranteed by CMOS manufacturers over a range of temperature and output loading. Parameters are also guaranteed over a range of power supply voltage VCC, typically 5.0 volts plus or minus 10%. The data sheet in Table 3-3 on page 94 specifies values for each of these parameters for HC series CMOS. Notice that there are two values specified for VOH-min and VOL-max, depending on whether the output current, IOH or IOL, is large or small. When the device outputs are connected only to other CMOS inputs, the output current is low, e.g., IOL is less than or equal to 20 microamperes, so there's very little voltage drop across the output transistors. In the next few subsections, we'll focus on these pure CMOS applications. The power supply voltage VCC and ground are often called the power supply rails. CMOS levels are typically a function of the power supply rails. VOH-min VCC minus 0.1 volts, VIH-min 70% of VCC, VIL-max 30% of VCC, VOL-max ground plus 0.1 volts. Notice in Table 3-3 that VOH-min is specified as 4.4 V. This is only a 0.1 V drop from VCC. Since the worst case number is specified with VCC at its minimum value of 5.0 minus 10% equals 4.5 VDC noise margin as a measure of how much noise it takes to corrupt a worst case output voltage into a value that may not be recognized properly by an input. For HC series CMOS in the low state, VIL-max 1.35 volts exceeds VOL-max 0.1 volts by 1.25 volts, so the low state DC noise margin is 1.25 V. Likewise, there is DC noise margin of 1.25 volts in the high state. In general, CMOS outputs have excellent DC noise margins when driving other CMOS inputs. Regardless of the voltage applied to the input of a CMOS inverter, the input consumes very little current, only the leakage current of the two transistors gates. The maximum amount of current that can flow is also specified by the device manufacturer. IIH, the maximum current that flows into the input in the low state. IIL, the maximum current that flows into the input in the high state. The input current shown in table 323 for the HC00 is only plus or minus 1 microampere. Thus, it takes very little power to maintain a CMOS input in one state or the other. This is in sharp contrast to bipolar logic circuits like TTL and ECL, whose inputs may consume significant current and power in one or both states.